So in this class, you would see a whole lot of functions, different kinds. You know, we had 1 plus 5x minus x squared. We could have x cubed plus x squared plus 1. So you could have a whole lot of functions, but what we want to keep in mind is all of them are families of functions. In the sense, if you understand the basic function, every other thing is simply a transformation or a change made to the original function. Easier way to remember this, take this classroom, and if you take me as a reference, and if I'm the original function, you're all different people, but I could say you are some version of me altered in many ways, correct? For all human beings, and I could make the same argument. What do you mean?
Lewis.
Lewis. Lewis is a person of his own, and I could be a transformation of Lewis, change a bunch of things, and I'll be, part Lewis. So it's true. We've all got something in someone else. So what I'm trying to say is what we have is simply one function, but functions are typically families of functions. So I can make changes here and there, and I'll get a new function. What do I mean by that? So suppose I have f of x is equal to x squared. We all know what that is, right? If we graph that, it is going to look like a parabola. Now, that original function, I'm going to make a transformation. I'm going to move to the right on the x-axis. So all I have to do, and let's say by c units. What would that mean? I'm making a change to the x-axis because I'm moving right or left, which simply means I'm changing the x values. So I have to make a change to x. And how many steps am I taking? I'm taking c units to the right. So here, f of x minus c. Common mistake. People will put x plus c because you're going to the right, but actually it's the opposite. So I'm going to write it as x minus c squared. Of course, parentheses. Yes? You don't have to expand or FOIL on an exam unless it's absolutely necessary, but I'm going to do it just to demonstrate something. So I have x squared. If I FOIL that, I'll get x squared minus 2xc plus c squared. Correct. Give me a number for c. Don't give me negative out. I mean, I could do it, but still. 8. Let's say equals 8. So that would mean I'm moving to the right by how many units? 8 units. So I'll have x minus 8. That's an exponent, so make sure you put that within parentheses. But we are plugging in the value for c. C is 8. Do you see C there? No. How about here? Is there a C?
Yeah.
Going to put 8. Is there a C?
Yeah.
Explain. Good. Now, if I simplify, x squared minus 2x times 8 plus 16, bad math, minus 16x, 8 squared is 64. right? Now you look at that equation or a problem and you may say, oh, that's an entirely different function, right, by the looks of it. And in your mind, oh man, another equation, another function, so math has a whole lot of functions. But if you closely observe that I got to this function by looking at a very basic function, which is xy. So if that looks like a u parameter, that is also going to look like u. But only difference is that this one will be 8 units away from the origin. Does that make sense?
Which another easier way to figure out whether it's going to be moving left or moving right is just again, anything in the parentheses is the opposite of what it means. So
Exactly, when it comes to the x-axis.
yeah.
So in a similar manner, if we have to move to the left, by C, and I don't want to, expand, we get the point of that. So I'm generating one function from another, from the basic function. So I'm moving to the left, so I have to add C to the original function. So let me write it this way. F of C plus C to X. You get F of X plus C. So this is the original function. That is the function that moved left.
Just outside the parentheses.
Right, so let's say if I want to move up, I have to keep on increasing the value of y, right? That's what moving up the axis would mean. So if I have y is equal to f of x, instead of making the change to x, I have to make the change to y. So add c to y, only on the right hand side. And that would move the curve up by c units. In a similar manner, if you want to move down, what would we do? You subtract c from y, you'd have y is equal to f of x minus c. So you could put it in, simplify, change, you'll get a new function, but that new function actually came from a very basic function, x squared, which is what we'll call, functions as families, because everything is a change made to the basic original function. Are we clear? I'll show this using a graph. Well, we'll start with x squared. That's our standard problem. Now I'm going to move this to the right by c units, and I simplified it, or not simplified it, I kind of expanded it out and wrote it in that way. But I know when I graph this, it better move to the right by 8 units. So you're at 0, we have to get to 8, window from negative 2 pi to positive 2 pi. Okay, I'm going to type in this one. Did it move? It moved. So even though this equation doesn't look like as if we move this 8 units to the right, in reality, this came from moving that 8 units to the right. Looks completely different, but you can identify that it is a problem. And we all know this is a quadratic equation, quadratic expression. In a similar manner, if I want to move it to the left, this time, since we didn't follow, I'll simply do x plus a slide and graph move to the left. Good. Okay, give me a number for C so that we can move up or down, and let's keep it with under 6. 5, 4. I like 4. I like multiples of 2. No. So plus 4 has to move up by 4 units. Yes, it did. And in a similar manner, I could do minus 4. Down by 4 units. So you see the concept of transformation. Every other function in math sort of has a origin function. Should we go with 4 again? 4, I have x squared. I'm going to put 4x squared. So 4 squared, no, 4x squared. Am I making a change to y or am I making a change to x? Y. I'm multiplying 4 to y. Let's say what happens. So the original curve is x squared. The second curve, first, second. What happened? Shrunk, right? So when you were making a change to y and c was bigger than 4, so it shrunk. Now, of course, you can look at it from the perspective of y or perspective of x. This is where sort of it gets confusing. We made the change to y, so technically we want to look from up there, right? So it has to be from the y-axis. Think of it this way, think of a rubber band, right? When you multiply it by a number bigger than 1, you're actually stretching that rubber band, right? It's going that way. And that stretch this way is similar to a shrink this way. Correct. And if I put a number between 0 and 1, let's do 1/4. And you get something, so expand it. The rubber band analogy will not work, but let's think of pizza dough, right? So if you have dough, ball of dough, and if you multiply by 1/4, which is between 0 and 1, think of you're pressing the dough from top. What happens to the dough when you press? It kind of stretches out. So it is the same thing. In a problem like this, it's kind of moot point, as you see, has to realize, you know, is it stretching and along the x-axis or y-axis? But the key thing to remember, I'm going to erase this side. So you have f of x, and you multiply by c. So y by c. So we have y equals c times f of x. And the requirements, the first requirement is I want it to be bigger than 1. Positive number bigger than 1. And we know right there, it kind of, you're stretching it like a rubber band. So this will stretch. Right? And if you pick and multiply a number that is between 0 and 1 and multiply by 1/4, I will get c times f of x to be a press, or I can simply say, let's say, expand. The book would call it as stretch and shrink. So it really comes down to how you visualize. For instance, the same problem, if I looked at it from this side, I am actually shrinking from the x, right? And stretching along the y. Yes, excuse me, along x. So the same process, if I did it to x, it'll just flip. Right? The stretch would become shrink, shrink would become stretch. So putting it within the parentheses, can someone tell me why? Because I'd like to demonstrate that the change is to the y.
No,
To the x, right? I'm trying to change x. Last time I simply multiplied, right? This time what I'm trying to do is I'm going to make a change to x, which is why I'm putting an x inside the parentheses. So second insert, I'm going to change x to 4x. Good. Let's see what happens. Shrink along x-axis, right? So here was viewing as a stretch. If say it's bigger than 1, it's the same argument, it becomes 3 times f of x. But what was stretching, like a rubber band, here it is shrinking along the x-axis, right? So the stretch became a shrink. Good? Do you follow? Yes. So
You're saying multiply x and values, but at the very same time, you're still doing the seeds of.
Oh, thank you very much.
Yeah.
So that's the C times.
Yeah.
Got too excited. My bad.
X axis.
If I pick a number between 0 and 1, still I'm making the change to x. Naturally, we should sort of see a stretch, right? Let's see if we get that. Going to change the 4 to 1 over 4. 1 over 4 is simply, x squared over 4. So delete, over, divide, 4 squared. Multiplying by 1 over 4, same things, dividing by 4. Well, that makes sense. So say, in this case, you're kind of, stretching it this way. So stretch along the x-axis. The book probably wouldn't use the term expand, probably use shrink. Now, I don't use that shrinking part when it comes to y at the very beginning, because it's sort of as hard to see for a person who's first learning. So, but the expansion part, it's easier to see. So, any questions here? Are we clear? So we added, we subtracted, we multiplied, and in multiplication, there are 2 ways. You either multiply by a number bigger than 1, or you multiply a number between 0 and 1. And long time ago, maybe the first day of class, the second class period, I said you can change the x in a function to minus x. And if you get the same function, then is it even or odd? Even. If you have x and you multiply, you change it to negative x and you end up getting different function, a flip function, then it is odd, right? So that multiplication by negative or any negative number is what we call reflection, right? When you reflect along the x-axis, you're simply multiplying x by positive x, right? Positive number. So you have x, let's say you multiply by positive 1, the function that will really work for this, let's just say, let's adjust the line 0 to 4. Okay. We'll do x squared. That's the graph. Yes, only the positive side. Now, we're going to take negative 5 to 5.
-5 to negative.
I get all values, right? Now, that is y equals x squared. If I change okay, right, it just flipped over. So it is reflecting about the x-axis. Multiply by a negative number to y, you are flipping or reflecting about the x-axis. If I multiply by a negative number to x. So would we see a change? No, but imagine this way, you have the positive part and let's say the negative part is not there. When you multiply by x squared, you're just flipping it this way. So if you multiply x by -1 or a negative number, you reflect about the y-axis. If you multiply a y by a negative number, you reflect about the x-axis. Does that make sense? Now that transformation is what we call reflection. So there's this composition, f compose g of x, g compose f of x, two cases. I wrote the remark that f compose g is not equal to g compose f unless it's these two cases. So let's consider the first one. That would simply mean f of g of x. So every x in f will get replaced by g of x. So I am going to put a parenthesis here. So that we will know that you're replacing all of x. So that is our function. So every x will get replaced by g of x. So think of it this way, g of x comes in and bumps that x out and replaces by square root of x plus 1. Good. So if I write this, I would write it as all of that will go in. So square root of x plus 1 squared. There is no x there, so I'm going to leave it as is. Good. Personally, this is the best way to keep the function. But if you want, you can FOIL this and then write it in an expanded version. That's entirely up to you. How about g of f of x? The order mapped, so it's g of f of x. So f has to go in for x in g of x and replace every single x. So g of x is square root of x plus 1. So f comes in, bumps that x out, so you have square x squared plus 1. Moves in, kicks that x out, so square root of x squared plus 1 plus 1. Right? This and that are not the same. So if you expand this, this is not going to look anything like that. But you can verify this easily using the calculator. You graph this and you graph that, completely different functions. Are we clear? So I'm going to let you try one before we move on. I'll leave this part, just change the function. So f of x is x cubed minus x plus 1. G of x is 4x squared. You should be able to simplify f of g of x, but g of f of x will take extra work. So This you can simplify, that will take some time. As I went along, I saw few mistakes which I went around. I saw a few mistakes which I'd like to clarify. So this part, putting or replacing x by the function, most of you got that part right. So once again, I would recommend that you put parentheses around x so that you know exactly what you're replacing. So here I have x cubed minus x plus 1, and g is going to come in. It's going to replace both of those x's. When I write this out, I would have 4x squared cubed minus 4x squared, and then plus 1. But so far, mistake that I saw is this. That is incorrect. You guys are thinking of this. X squared times x cubed, you add the powers. You have 2 plus 3, you get 5. But you have x squared cubed, then you have to multiply those two, so you have 6. And the cube gets applied to each of those terms. 4 cubed, 64, x squared cubed, x raised 6, minus 4x squared, plus 1. That one was 8. So, do take note.
And a good way to remember as well is just, again, when it comes down to exponents, everything has to be quote unquote more extreme. So, normals, addition and subtraction doesn't affect them. However, when it comes to multiplication and division, they think of that like addition and subtraction. Basically, think of it like you're going up a level in difficulty, or like how much it is.
Okay. So 4 x squared, we have x cubed minus x plus 1. So f of x is going to come in and bump the x out and replace it. So you have g of x is equal to 4, x gets replaced, x cubed minus x plus 1, x2. Good? That's all. Very unique mistake. If life was this easy. So writing it this way, 3 plus 2, or even 3 times 2, x raised 6, minus x squared, 1 squared, 101. We have to FOIL. So this times another term would mean you have to FOIL and simplify. And that's what I said. This is going to take forever to simplify. Right? By all means, if someone asks me, FOIL it and then simplify, or leave it as is, I'll go for this because it's in product of practice. So this is the better way. Good.
So my question is, if we're on the homework at the very least.
In this section, so I'm going to keep it like. It's 1.5 exponential functions, and it is good to, follow exponential and logs after talking about convolution. I'll tell you what. So if we have a function y is equal to, say, some number P. And E raised R2. Now, I write it this way so that you guys can remember these per geometry.
When you say per order,
Yes, easier way to remember. Anytime you look at an exponential function, think of the deodorant.
I didn't even know that was a deodorant.
There is one.
There's like a shampoo, it's per class.
Never heard of it.
Okay, think of the shampoo then. I think there's a difference.
I just remember.
I might have stopped, I don't know, but point being, easier way to remember an exponential function, P, E, R, T. Here, of course, this is a function of T. Standard structure, we know what that E is. E
It's 7 something.
right? And P is what we call the initial value. Initial value simply means value when T equals 0. And R is the rate. Standard terms. Of course, you can replace P by another letter, R by K, or say T by X, doesn't matter. Regardless, it is still an exponential function. If R is positive, then Y represents exponential growth.
So function.
Things would grow exponentially.
If R is negative, then it's decay.
Very good, yes. If R is negative, then Y represents exponential decay. Now, it is going to be exponential, but even exponential can be determined, or even exponential growth can be, scaled up or scaled up. How do we do that? The rate. A rate of 2 is slower than a rate of 4. So as the rate gets bigger and bigger and bigger, things would just keep on growing faster. Same here, as the rate increases, R becomes bigger and bigger and bigger in magnitude, then the decay will be really fast. Are we clear? Yes. A more generalized version right. A, B raised CX, either think of the alphabet or ABC. Either would work. So A, B, C. So A would be the initial value. In this case, x is equal to 0. B, if you go back to that, what is the value of B? E. And C is simply on x is 10. Good. Now, that B could be any number, 2, 3, 1/2, 2/3. It could be any number. And this is the special case because this is the natural exponent 2.7122. I will do 1 or 2 examples on this next time. The book has exercises on, combining simple exponents. Now, those are things that you must have learned in algebra. It is there for review, but I will do 2 examples that apply so that you know what we're trying to reproduce. Have a good day. I'll see you on next. Yeah, questions?